Hello everyone. In today's video, we are going to start working on exercise 7a. It is from book D3 and 8th edition. So in this exercise, we are going to solve different problems regarding the pyramids. Uh, Before starting work on this exercise, let's discuss what is a pyramid in the first place, and then we will start working on the problems. The topic is mensuration, and in this topic, we are going to deal with the surface areas and the volume of different three-dimensional objects. And in these three-dimensional objects, today we are going to solve problems of the pyramids. Here is an example of the pyramid drawn in front of you people. Everyone knows about the Pyramid of Giza. By visualizing this, we can have a very clear picture of the pyramid and different aspects of the pyramid. For example, there may be some base of this pyramid acting as the floor of the pyramid, and all these four vertices, when raised to meet at a single point, we obtain a pyramid. Before moving further, keep in mind that there are different types of the pyramids depending upon the base of the pyramid. This is the base. There are some pyramids which have the base to be square based. Then we have some rectangular based. Then we have some triangular based pyramids. So, according to the shape of their base, we differentiate between different pyramids, and moreover, there is there are two more things which I need to tell you people about the pyramid. That is slant height. You can see that if we take the midpoint of one side of the base and join this midpoint to the apex or to the top of the point, then we obtain a straight line which is called the slant height of the pyramid. Each triangular face or each triangular side is called a face, and from the apex, a vertical line drawn to the base, that is called the height of the pyramid. So these are very important things to know about a pyramid whenever we need to solve. For example, the when we have to find out the volume of the pyramid, that is 1 over 3 multiplied by base area multiplied by height. So this base area involves this area. In case of a triangular pyramid, the base area is equal to 1 over 2 base multiplied by height, where this base and height belong to this triangle. And in case of a square pyramid, we have base area which is equal to L square. Similarly, base area can be equal to length multiplied by width whenever we have the base to be a rectangle. So moving to the first question, and first question of exercise 7a, triangle, pyramid OABC is a triangular pyramid with a base area of 15 centimeter squares and a height of 4 centimeter. Find the volume of the triangular pyramid. So in this pyramid, we are already given the base area, and we don't need to find out the value because it is already given. So we can just use this in the formula of V equals 1 over 3 base area multiplied by height, 1 over 3 as it is. Base area is equal to 15 centimeters and height is equal to 4 centimeters, and it will be by solving this all we can obtain easily. It is 20 centimeters cube. Keep in mind, whenever you are going to write your answer, you have to mention the uh, units correctly. So In case of volume, it must be centimeters cube. And the question number three, question number two is just like question number one, where you are given the base area and you are given the height, and you just need to put the values. In question number three, again we are going to use the same method, but there is only one minor difference in question number three and question number one, is that we are now given the right angle triangle's dimensions xy, which is equal to 7 meters, and yz, which is equal to 4 meters. It means here we need to find the base area first, because there are two very important things in finding the volume. Number one, the height of the pyramid, and number two, the base area. So here in this case, you people are given the height of the pyramid, which is equal to 5 centimeter, but for the base area, keep in mind that it is a triangle, and it is a right angle triangle, which has one side which is 7 meters, and the other side which is equal to 4 meters. So before solving, or we have to find the base area, which is equal to, for the area of the triangle, we have the formula 1 over 2 multiplied by base multiplied by height. So it is 1 over 2, it is 7 multiplied by 4, which we obtain to be equal to 14 meter squares is the base area. Now the formula for the volume is equal to 1 over 3 base area, which is equal to 14 here, multiplied by height, which is 5 given in this diagram. So 1 over 3 multiplied by 14 multiplied by 5 is 70 over 3, which is an improper fraction. So you need to convert this into a proper fraction, and its proper fraction will become 23 whole 1 over 3 meters cube, or else you can write this answer in a decimal form if you are allowed to use the calculator in your exam. So 23.3 meters cube will be the volume of this pyramid. Similarly, we have question number 4. There is a very minor difference again between question number 4 and question number 3 or 2. A pyramid with a triangular base has a volume 50 centimeters cube. Here, the only difference is that from the statement, you have to draw a diagram first. To have a clearer image of the problem, you have to draw the diagram. A pyramid with a triangular base has a volume of 50 centimeters cube. So here we are given the volume, which is equal to 50 centimeters cube. And if the base and the height of the triangular base are 5 centimeters and 8 centimeters respectively, find the height of the pyramid. So starting with the base, its base is a triangular face, and whose one length is equal to 8 centimeter, and its height is equal to 5 centimeter. Again, the base area can be found by using the same formula, 1 over 2 base multiplied by height, and putting the values 1 over 2, 5 multiplied by 8, we get it to be equal to 20 centimeter squares. And this 20 centimeter squares will be used in the formula to find the volume. Sorry, volume is given in this question 50 centimeters cube. So write the formula V equals 1 over 3 base area multiplied by height, and volume was 50, which is equal to 1 over 3, base area is 20, and height we need to find in this question. To find the height, we have to make it the subject of the formula, and it will become h is equal to 50 multiplied by 3 divided by 20, and the total answer becomes equal to 7.5 centimeters. So this is how do we start working with a statement which is given without the diagram. You have to understand that in a diagram and in a statement, what relations can be developed. In question number 5, the volume of a square pyramid with a height of 12 meters is 100 meters cube. Find the length of its square base. It's just a different case. It is not a different type actually. We are just given that it is a square pyramid. A square pyramid, when we understand it, it is a square base whose area is given. Let's see, volume of the square pyramid with a height of 12 and 100 meters cube volume. So its volume is given and area, or we don't know what's the area, but we know that if this length is L and this length is L, then total area will be L square. Okay, later on we will be using this. Here we are going to write the formula again. 1 over 3 volume is equal to 1 over 3 base area multiplied by height, and using the values 1 over 3 as it is, volume is equal to 100. Base area, instead of base area we can use this L square multiplied by height h, which is 12 meters. So to solve this, we can make the L square as the subject of the formula, or isolate it on one side and shifting all the values on the other side. We get 100 divided by 4, and it will be 25. As L square is equal to 25, so taking square root on both sides, we get square root of 25, and length of this base is equal to 5 centimeters. So these are easy questions, but in question number 13, you can see VPQRS is a pyramid with a rectangular base of side uh, 10 centimeters by 8 centimeters. Given the volume of the pyramid is 180 centimeters cube, find its height. So before starting, and in second part we need to find the total surface area. So for the height, what we can do is, first, look at the given data. You are given a rectangular base. We have to keep in mind that its base is rectangular, so some values will differ. We will discuss them later. And the sides of the rectangles are 10 centimeters and 8 centimeters respectively, while the volume of the pyramid is given to be equal to 80 centimeters. So according to the formula of the volume, 1 over 3 base area multiplied by height. Now volume was equal to 180 equals 1 over 3. Instead of base area, now we are going to use 10 and 8 as the side of this base, and we know that as it is a rectangle, so 10 multiplied by 8 will be the base area, and height we need to find in this case. So isolating it on one side, we get 180 multiplied by 3 divided by 80. And just a second, let me calculate what this values gives us is 6.75 centimeters. So this h is equal to 6.75 centimeters, height of the pyramid. Now coming to the second part, the total surface area. The total surface area of a pyramid. To understand the total surface area, uh, I say that you need to draw the net of the pyramid. For that purpose, here I have drawn a net of the pyramid. Just let me show you completely. According to the dimensions given here in this diagram, in this diagram, see that its base has the length 10 centimeters and width 8 centimeters, while the slant height will be different in this case. For example, here this slant height will be same as in this triangle, and for these two triangles the slant height will be different depending upon the sides. Now consider one triangle, like I'm just circling this one triangle, and I will be drawing this here again. In this triangle, isosceles triangle, we have the base to be equal to 8, and we need to find the slant height, which is this height, and here in this diagram it will be like this. So just omitting this side, you have a right triangle, and in this right triangle we need to find the slant height by using different techniques. Now look at this, that height of the pyramid is 6.75. If we I'm sorry, just omit this, ignore it. Look at this diagram from V to the base. This is a straight line. Consider this as a straight line, and its height is equal to 6.75. And if I draw a line from this to the midpoint of QR, and this will be the slant height of the face QRV. It is a right triangle now, and here we have half of 10, which is equal to 5 centimeters, and this height, which is equal to 6.75. The slant height of this face can be found by using Pythagoras theorem. So Pythagoras theorem says, let's say that this one is L1. So L1 square equals 5 square plus 6.75 square. And all by solving all this and taking square root on both sides, L1 becomes equal to 7.846. 7.846. Instead of 7.846, I'm going to write just 85 centimeters. So we now find this slant height, and this slant height is basically in this net will be used as this height. So area of this triangle, let's say that this is triangle 1 and this is triangle 2. Area of the triangle 1 will be 1 over 2 multiplied by base, which is equal to 8, and height, which is 7.85. You can find these values, the solution of this value, by using calculators. Now coming to the other diagram or the other triangle, here we have the base equals 10. But again, now if in the same shape I draw a line like this here to the midpoint of PQ, and then the side PQV has a slant height. When we join this midpoint to the apex V, we have to use the Pythagoras theorem again for L2 square equals, now this length is half of this 8, so it is 4 square plus 6.75 square. And by solving this, L2 is equal to 8.4001. 8.4, we can just write this. Now as we have this length, like this length, which is 8.4, so base multiplied by height, its formula will be, its area will be 1 over 2 multiplied by base is 10 in this case, and height is uh, uh, 8.4. By using calculators, you can find out this value again. Let me calculate these two values. We obtain this value plus this one plus area of this base. We can have the area of this base is 80, and I'm just putting all these values correct directly in one place. We obtain 226 centimeters cube, and it is 226 because it is correct to three significant figures as given in the statement. Let me show you the statement again. No, there is no three significant figure, but I have shown it in three significant figures just for the sake of ease. So I hope that in this exercise you have come to know about how to find the area, surface area and volume of the pyramid. In next video, we will be solving some other shape like might be cone. Till then, thank you very much.